Hello students, today we're doing solutions to systems of equations. So today we're going to be able to analyze a system of linear equations using slope to predict if it will have one, infinitely many, or no solutions. So we can have one solution, we can have zero solutions, and we can have infinite solutions. Same as with just one equation. Okay, hopefully you recognize that these are my options when we have just one equation. Now we have a system. We have two equations at the same time, which means on a graph, I have two lines. So the number of solutions is directly correlated with the number of intersections when graphed. So just to set this up, I'm going to draw a line through each graph. Doesn't matter exactly where, but I'm trying to make them look kind of the same. Okay, we're just drawing a rough picture of what each of these look like on a graph. When we have zero solutions, that means we have zero intersections. If we have zero intersections, that means my two lines never, ever, ever, ever touch. We have a special word for that. That is called parallel. When we have one solution, that's one intersection. So that means I can have a line that crosses here, 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 doesn't matter where, but I have one intersection, okay? And when I have infinite solutions, that means I have infinite intersections. And what that ends up looking like is from one end of forever to the other, my lines cross at every single point, meaning they're directly on top of each other. So we have the exact same line. Okay. Now, what do you notice about the slopes and the y-intercepts in each spot? I'm going to put M and B each time for slope and y-intercept. Okay. When my lines are parallel, my slopes are the same. But my y-intercepts, where they cross the y-axis, they are different. When I have two lines that cross only once, notice I have a negative slope and a positive slope. My slopes are definitely different. And my y-intercepts are different. When I have the exact same line, well, my slopes are the same. And they both cross in the exact same spot on the y-axis. So my y-intercepts are the same too. And we can use this to figure out if two equations without a graph, if two equations have 0, 1, or infinitely many solutions. There's actually 3 different ways to do this. And so I'm going to show or explain all 3 ways. The first way is shown in these steps. Okay? If you're like, I love converting to slope-intercept form, this is for you. We have been doing that a lot. I see a lot of students preferring that method. So if that is how you want to do it, let's do it. Okay? To keep my work neat, I'm going to split this down the middle and rewrite my equations. We've been doing this for a while, so I'm going to do it relatively fast. Okay. Step 1 is convert to slope-intercept form. So all like these are in standard form. I need them to look like y equals mx plus b. Okay. So I'm going to add 2x to both sides. Y equals 3 plus 2x, and y is already alone, so that's great. Add the x term over. I'm adding because it was negative. I'm left with 2y equals 6 plus 4x. Divide by 2 to everything, and I'm left with y equals 3 plus 2x. So, solve for y. I notice that my slopes are the same. I'm going to use a highlighter. My slopes are the same, and my y-intercepts are the same. Remember, if both things are the same, then it is infinite solutions. So on Delta Math, I would put infinite. Okay. The second option is we now have access to Desmos.com. Plug your equations into Desmos. Okay, if you do that for these ones, you will get parallel lines. If you get parallel, that means that your slopes are the same, your y-intercepts are different, and you have zero solutions. So 0 intersections, 0 solutions. Okay, and the last way, this is the way that Delta Math shows. It's pretty cool. It's a little different, all right? So it's also the second fastest. Like, this way is the slowest, this way is the fastest, and this way is the way that Delta Math shows, okay? And it's the middle way. What I'm going to do is I'm going to make my x terms the same. The same number, but different signs. Using distributing. Okay, sounds like a lot, but again, I want to show you what Delta Math is showing you, okay? What I mean is I want to get, I'm sorry, I've got the baby. Okay, what I mean by this is I want to multiply the whole equation by both whole equations by a number so that these two numbers become the same but different signs. So notice I already have one that's negative and one that's positive, so I don't need to mess with any negatives, okay? But I know that 3 and 2 both go into 6. So I'm going to try and make them both be -6 and +6 respectively. So -2 times 3 is -6, and 3 times 2 is +6. So I know that I'm going to get 3 times -2 to be, and 3 times 2 to be what I want. So I'm going to distribute 3 into the whole first equation, and I get -6x plus 3y equals 9. And on the bottom, I get 6x plus 4y equals 16. What I'm going to do for step 2 is I'm going to add the equations together. Okay, like things go together, same sides of the equal sign go together. So -6 plus 6 is 0. My goal was to do that, okay? I wanted to cancel something out. 3 plus 4 is 7y equals 9 plus 16, which is 25. Step 3 is going to be solve for y. I would divide by 7 on both sides. I get y equals 25 over 7. I got y equals a number. So that means that I have one solution possible because I got y equals one thing. Okay? So depending on what you like, if you like to go with what Delta Math does, there you go. If you like graphing, there you go. If you like solving for y, because we've been doing that for the longest, there you go. 3 different ways to do the same kind of problem. Try your homework out. Email me if you have any questions. Thank you.